On April 8th, so just a few days ago, a 7-story parking garage being built in South Philly collapsed during construction.
Yeah, it's an absolute nightmare.
It really is. And, for every contractor listening right now, here's the part that should honestly keep you awake at night. The permits, they were flawless.
Right.
The inspections were completely up to date. I mean, everything on paper said this site was safe. So we really have to ask, how does a fully compliant 50-ton precast concrete roof segment just, suddenly fail during placement?
And then pancake multiple floors below it.
Exactly. Trapping 5 iron workers under all that rubble.
Well, I mean, it completely shatters this illusion we kind of cling to in the industry. We pull the permits, we get the municipal sign-offs, and we just assume that a clean paper trail means a safe job site.
Right, but gravity doesn't really care about your paperwork.
No, it certainly doesn't.
And the human toll here for Ironworkers Local 401 is it's devastating. We're looking at 1 worker confirmed dead, 2 presumed dead in the rubble, and thankfully 3 who were pulled out alive.
Just a horrific loss.
It is. And to you listening right now, whether you're a GC, a sub, or you're running a massive outfit, the whole mission of today's deep dive is to honor those victims by really educating the industry.
Yeah, we have to.
We're going to break down what a progressive collapse actually is, why the erection phase is the absolute most dangerous moment on your site, and the critical checks you have to mandate before your next lift.
Because if a permitted, heavily monitored project like the CHOP site down on Grays Ferry Avenue, if that can turn deadly in just seconds, it can happen anywhere.
Right.
So to stop it, we really need to pull back the curtain on the actual physics here. We need to look at the anatomy of a progressive collapse.
Okay, well, let me stop you right there, because I hear that term thrown around a lot in post-incident reports. What is physically happening during a progressive collapse?
So, at its core, a progressive collapse is essentially a chain reaction. It happens when you have a local failure, meaning just one single structural element giving way, and that propagates.
It overloads the pieces around it.
Exactly. It triggers this cascading global failure through the whole structure. The split second that first piece fails, the entire building is instantly forced to find alternative load paths.
But I'm guessing those secondary columns weren't engineered to handle that sudden transfer of weight, right?
No, not at all. So they buckle, the load transfers again, and the collapse just progresses.
Man, so it's kind of like, say you have 4 pallbearers carrying something incredibly heavy. If one guy trips and drops his corner, that weight doesn't just vanish.
Right, it instantly shifts to the other 3.
Yeah, and if their knees aren't perfectly braced for that massive sudden doubling of weight, the whole group just goes down.
That's a perfect mechanical analogy. And in precast concrete, you aren't dealing with a wooden box. You are dealing with segments that weigh anywhere from 10 to 50 tons.
Which is massive.
It's massive. So when that pallbearer drops his corner, it isn't just static dead weight transferring over. We are talking about severe kinetic energy.
Because, dropping 50 tons even just a foot changes the math entirely.
Exponentially, yeah. A 50-ton slab just resting on a pillar, that's a static load. The pillar handles that fine, but if that slab falls, gravity accelerates it.
So dynamic impact.
Exactly. The force multiplies. The pillar below isn't catching 50 tons anymore. It's catching a massive kinetic shock wave. It can't absorb that energy, so it just punches right through.
We've actually seen this happen in finished buildings before, haven't we?
We have, unfortunately. If you look back at the 1968 Roman Point disaster in the UK, a gas explosion blew out a load-bearing corner wall on the 18th floor.
Wow, 18th floor.
Yeah. So the floors above lost their support, crashed down onto the 18th, and that kinetic energy just pancaked the entire corner of a 22-story building straight down to the ground.
Just completely devastating. And more recently, there was the Champlain Towers South condo collapse down in Miami in 2021.
Precisely. That was the exact same mechanism. It started as a local failure. The pool deck slab punched through to the garage below, and that local drop just dragged the adjacent columns down with it.
Triggering the global failure.
Right. And here in South Philly, the GC, HSC builders and their precast sub, Precast Services Inc., they experienced this exact nightmare.
Yeah.
A single roof segment failed during crane placement, overloaded the temporary supports, and took down multiple levels. OSHA is in there now, but the investigation could take 6 months or more.
Which is tragic, obviously. But it's also sadly not an isolated thing, right?
No, not at all. When you actually look at Smart Business Automator's Market Intelligence Report, which, tracks these specific structural incident patterns, it's pretty glaring.
What do they flag?
It highlights just how incredibly often these cascading failures happen specifically during the erection phase of construction rather than after a building is totally finished.
Okay, wait, I'm stuck on something here. I mean, we over-engineer the final building to handle earthquakes, hurricane winds, you name it.
Right.
Why wouldn't engineers just automatically design the temporary bracing to handle the dynamic load of a dropped panel? I mean, why is this such a blind spot?
It seems obvious when we sit here and talk about it, but it really comes down to how the industry views a project's lifespan. There is a huge difference between the final engineered product and the temporary state of a building under construction.
Because it's fundamentally incomplete.
Exactly. During the erection phase, the permanent connections just aren't there yet. The grout poured into the shear walls, it hasn't reached the required PSI to cure.
Or maybe the welding is just like tack welds to hold things for the afternoon.
Yeah, precisely. The bracing is entirely temporary, usually just steel pipes bolted into concrete inserts. At this specific stage, the structure is vastly weaker than its final design.
I think the psychological trap there is that to the naked eye, it looks like a real building. It's huge, it's concrete and steel, so our brains just assume it's solid.
But it's an absolute illusion. Precast structures are so vulnerable during this window. Every single piece relies entirely on temporary connections to the pieces next to it just to stay upright.
Wow.
And you have massive lifts happening overhead. You have temporary shoring that has to hold perfect millimeter precise alignment until those permanent connections are locked in.
So basically, you've got this partially built, highly unstable structure fighting wind, vibrations from heavy equipment, the crane pulling on it, and its own dead weight all at the same time.
Yes. And here is the fatal gap. The temporary state is viewed by a lot of folks as just an assumed risk window.
Right.
The structural engineer of record, they design the final product. But the actual means and methods of getting to that final product usually fall entirely on the erector or the subcontractor.
So you're saying the underlying safety assumption during a lift is just don't drop the piece.
Tragically, yes. Every responsible contractor has an erection sequence, right? They have a bracing plan. But so many erection plans do not include a progressive collapse analysis for the temporary state.
But engineering is supposed to account for failure.
Exactly. If your entire safety plan relies on 100% flawless execution with zero mechanical failure or human error during a 50-ton lift, that is not engineering, that's gambling.
Man, that is a really chilling way to put it. You're gambling with the lives of the crew on the deck.
Yeah.
So let's pivot this to the listener.
Good idea.
We know the mechanics of the collapse now and why the erection phase is the danger zone. Let's talk actionable solutions. What does an owner need to mandate tomorrow morning to stop this?
Let's break it down into 5 non-negotiable checks before your next crane lift. And look, this isn't just a best practice recommendation, this is basic survival.
Okay, check number 1. Let's go.
Number 1 is the erection sequence itself. You have to verify, does the precast erector have a fully stamped plan from a professional engineer? And crucially, does that PE stamped plan show the sequence, bracing, and stability requirements at each specific stage of the build?
Meaning stage 3 has a totally different center of gravity than stage 6. You can't just rely on a start and end blueprint.
Exactly. The physics change with every single piece you add, which leads to check number 2, temporary bracing. Are your braces actually designed for real-world construction loads?
Instead of just like static dead weight.
Right. Too often, braces are calculated just to hold the panel's dead weight. But during erection, you have dynamic crane loads, you have these massive concrete panels acting like giant sails catching the wind.
Putting insane tension on a tiny steel pipe brace.
Exactly. The braces must be engineered for the chaos of the build, not just the calm of a finished building.
That is a great point. Which brings us to check number 3, connection verification. And this one gets me because I've walked 100 sites where guys just eyeball a temporary connection, slap a wrench on it, and yell, "Looks good."
Yeah, send it up.
Exactly. But engineering a perfect brace in some software program means literally nothing if the physical connection on the deck isn't locked in. That's where human error breaks the math.
But that is exactly what you need to formalize. It cannot be subjective. It can't just be a foreman's gut feeling. Who specifically is verifying these connections, and where is the hard checklist?
If it's not on paper, it didn't happen.
Right. If there is no documented paper trail for a temporary connection, legally and structurally, it does not exist.
Which flows perfectly into check number 4, the wind and weather protocol. You know what scares me about this one?
Complacency.
Yes. You hear guys say, we've done this 1,000 times, a little breeze won't hurt. I mean, that phrase is probably responsible for more fatalities than faulty equipment.
Oh, without a doubt. It is the ultimate friction point between safety and schedule. You need to know, objectively, at what exact numerical wind speed does the erection halt.
And who has the authority to make that call?
Exactly. Say the crane operator says it's too windy to control a 50-ton panel, but the PM is screaming about liquidated damages because they're behind schedule. Who wins?
It has to be an objective number.
Yeah.
Like an anemometer hits 25 miles per hour or whatever the limit is, and the lift stops, period. Safety has to override the schedule.
Precisely. Which brings us to the fifth and final check. And this is the one that most sites totally fail. Check number 5, the progressive collapse assessment.
Meaning, has anyone done the math on what happens if one element fails?
Right. Whether it's the PE, the erector, or the GC. If you have a broken hydraulic line or a snapped lifting strap or a buckled shore, what happens to the rest of the incomplete structure?
Do you have redundant load paths in that temporary state?
Yes. And if you do not know the answer to that question, you have a fatal gap in your safety plan. And this isn't just theoretical. Smart Business Automator's Market Intelligence Report actually shows that tracking safety compliance around these erection plans.
The bracing verifications, specifically.
Yes, verifying those plans is one of the most critical leading indicators for preventing on-site fatalities.
Center that in your mind for a second, right? It's not just about having a binder sitting in the site trailer. It's about translating that analysis into verified action on the deck.
Because a missing piece of paper doesn't just stall a project. As we're about to talk about, it basically locks the doors of your company forever.
Let's get into that ripple effect. Because if the moral obligation to keep your crew alive isn't enough to force change, and sadly, sometimes it isn't, we have to look at the business impact.
The aftermath of a collapse destroys companies, just completely levels them.
Picture your daily operations right now.
Yeah.
A collapse happens. The first thing that hits is that regulatory freeze.
Right. OSHA steps in. And those citations are brutal. For a serious violation, you're looking at fines of $150,000 or more.
Per violation.
Per violation. But if OSHA determines it was a willful violation, meaning they find emails or testimony proving you knew the temporary bracing was flawed, but you proceeded anyway, yeah, that fine becomes $150,000 per instance.
And honestly, the fines are just the tip of the spear. The insurance impact is what actually bankrupts a business. Let's explain how the EMR works here.
So your experience modification rate, or EMR, is essentially your construction credit score. It compares your workers' comp claims against the industry average.
And if you have a fatality or a massive collapse, that EMR is going to spike overnight.
We are talking premium increases of 20 to 40%, basically instantly.
But it's not just the cost of premiums, right? A spike in your EMR physically locks you out of the market.
Exactly. Algorithms just automatically filter out your bids. Municipal jobs, federal projects, large private developers, they have strict baseline requirements.
If your EMR jumps above a 1.0, you can't even submit a bid. You're disqualified before they even open the envelope.
So your revenue stream dries up immediately. Meanwhile, your capital is just bleeding out. Picture your site right now. A collapse means OSHA throws up yellow tape.
And your heavy equipment is trapped behind it.
Right. Your cranes, your lifts, your excavators trapped for 6 months during an investigation. You can't use them anywhere else, but you're still paying the leases.
Your schedule is totally destroyed.
Then you add in the legal liability. Wrongful death lawsuits from the families, potential criminal negligence charges against leadership, and the reputation damage is just permanent.
Think about HSC Builders and Precast Services, Inc. The companies on that CHOP garage collapse.
Whenever their names are Googled by a potential client, this April 8th tragedy is what's going to dominate the search results. They will never be the same.
No.
In construction, trust is the fundamental currency. When a worker steps onto a 5th floor concrete deck, they are trusting leadership that the engineering holding them up is mathematically sound.
And a progressive collapse shatters that trust instantly.
It really does.
And while framing this through frozen capital and lost bids is, a reality check for a business owner, we have to bring it back to the human element.
Always.
Because the fines, the lawsuits, the EMR algorithms, they're just numbers on a spreadsheet. The ultimate irreversible cost of failing to do a progressive collapse analysis is the empty seat at the dinner table for the families of iron workers, Local 401.
Yeah, it's the trauma those 3 workers who were pulled out of the rubble are going to carry for the rest of their lives.
It is the starkest possible reminder that the paperwork we demand, the objective win checklists we follow, they aren't bureaucratic hurdles designed to slow you down. They are life-saving mechanisms.
Absolutely. So as we wrap up this deep dive, I want to leave you with a thought to chew on as you head out to your sites tomorrow.
What's that?
Look at the macro trends in our industry right now. We are rapidly moving toward modular off-site construction. Everyone wants to save time and reduce on-site labor.
Which means more precast components.
Exactly. More precast, much heavier lifts, and a massive increase in the number of temporary states a building goes through before it's finalized.
So the temporary windows are getting even more complex.
Yes, you have to ask yourself, are our safety engineering protocols actually keeping up with our push for faster modular construction?
That is the exact question you need to be asking your team. Think about the active projects you have running right now. Do you know for an absolute fact that your precast erection plan includes a progressive collapse analysis?
Don't wait for an OSHA inspector to ask for it after an incident.
Right. Demand it before the next crane lift. Make sure the engineering actually supports the brutal reality of the build, not just the illusion of control.
Physics does not care about your schedule.
No, it doesn't. If you know a contractor who is managing precast erection or heavy structural lifts right now, send them this deep dive. It could save their crews' lives and protect their business from a catastrophic failure. Hit follow on whatever app you're listening on so you don't miss tomorrow's intel.
And if you want to learn more about how AI can help scale operations and maintain compliance without drowning in paperwork, visit smartbusinessautomator.com.
Stay safe out there.